Section 5-5 is on the mean value theorem and Rolle's theorem. The objective of this section is to use the mean value theorem to find the point in an interval at which the instantaneous rate, that's f prime at c, or the slope of the tangent line, is equal to the average rate. That's the f of b minus f of a all over b minus a. That's the slope of the secant line. And you've already worked with that a little bit and saw that with mean value theorem, and you've also worked with Rolle's theorem. Just remember the connection here that we're trying to make from what we've studied in the first half of this chapter is we're trying to come up with a method for finding the exact value for the definite integral. And it turns out that with a Riemann sum, we had a method that we could use to approximate the area under the curve using rectangles. And not only that, we said if we were really, really careful on how we picked our sample points in each subinterval, we could come up with the exact area under the curve. That is, the area of each rectangle would represent exactly the area under the curve for each subinterval. And so that's the question. How do we come up with those sample points? It turns out mean value theorem is going to help us do that. And that's what we'll cover in the next section. So that's where we're headed. But one last topic here we need to talk about. We've seen several theorems now. And basically, most of our theorems, if not all of our theorems, have been in the form of an if-then theorem, where you have if and then some hypothesis or condition, and then you have a conclusion. And it's important to understand the difference here between what we call necessary conditions versus sufficient conditions, and not reading too much into that theorem. It's easy to do. That you might look at a theorem and say, well, if I meet the conditions, I know that the conclusion's true. That's, of course, always the case. But you sometimes read a little bit too much and say, well, if the conditions are not met, that means the conclusion is not met. And that's not true. That's not necessarily the case. And we'll see that here with the difference between these. So let's start out with sufficient conditions. And if you have sufficient conditions, you have the following here. That you have a conclusion that can be true even if the condition is false. So even if your condition, your hypothesis is false, with sufficient conditions, it turns out your conclusion could still be true because they're only sufficient. That's one possible way for the conclusion to be true, but there are other potential ways for that conclusion to be true. So just because you don't meet all the conditions doesn't automatically mean the condition has to be false, or the conclusion has to be false. It is possible that it could be true. Here's an example of that. If A is equal to 2, it's obviously a simple example here, but at least illustrates it for you. If A is equal to 2 and B is equal to 3, then A plus B is equal to 5. Well, obviously, if A is 2 and B is 3, then 2 plus 3 does, in fact, give us 5. So if we meet those conditions, we're guaranteed, of course, that the conclusion is true. However, that's not the only way for that conclusion to be true. If A was 1 and B was 4, the conclusion would be true. If A was 0 and B was 5, the conclusion would be true. And we can keep going on and on and on. There are lots of ways for that conclusion there to be true. So just because I don't meet the conditions, just because A is not 2 or B is not 3, whichever the case may be, or both of those, doesn't mean that A plus B is not equal to 5. Just because I don't meet the conditions does not automatically rule out that the conclusion has to be false. Okay, those are sufficient conditions. As long as I meet these, I'm guaranteed the conclusion will be true. However, there are other possible ways that the conclusion could be true. Now let's compare that with necessary conditions. Necessary conditions means that you have a conclusion that can only be true if the condition is true. The only possible way for that conclusion to be true is if your conditions are true. These are necessary conditions. Okay, so big difference here between sufficient versus necessary. So let's take a look at an example then to help illustrate that. So this one says if A is equal to B, then A minus B is equal to 0. Now obviously if A and B are equal, then their difference is in fact 0. So if A and B are equal to each other, then we know that the conclusion is going to be true. However, that's the only possible way that the conclusion is true. There's no two values that you can come up with for A and B that their difference is 0 other than A and B have to be the same number. These are what we call necessary conditions. The only way that A minus B is equal to 0 is if A is equal to B. Okay, those are necessary conditions. And that's the end of this second half of the section for us.